Today we're going to turn a cheap 4G LTE modem with Wi-Fi into an OpenWRT travel router. I found this comment section on the Hacker News ages ago, and they were talking about these cheap dongles. And all the dongles that I have here are from Huawei and ZTE, and you cannot install custom firmwares to them. But this one, you can install OpenStick to it, and I will link this article in the description. However, our agenda is to install OpenWRT and not OpenStick. This is the Shopee listing, and you can see there's a lot of dongles. You may not know which one is the compatible to the OpenWRT or OpenStick because they do not indicate the model. The original seller that I got it from has run out of stock, and this is the similar one. I don't know if this thing supports OpenWRT, but if you buy it, let me know. At least this thing says it's Qualcomm chipset. Now to the actual unit, here it is. It has a box. The box does not indicate the model, so we just have to open it up. And if there's nothing on the web indication or the web page, just tear the device down. Inside the box, there's a manual and the actual unit. You can plug this to a power bank. Now at the back of the device, there's the generic credentials. And you can slide it open to access the SIM slot. And you can see the IMEI sticker, a reset button, and the SIM slot. Plugging it into a power bank with a USB adapter to know the current requirements. Once the red light turns blue, you can now connect to the access point. Pay attention to this address. I just replaced it with main.html and I got in. So basically, there's no authentication. And here's the web dashboard. You can only choose the password, the network mode, 3G or 4G. And in here, you can change the IMEI. Just make sure you provide the correct IMEI. And I did not insert any SIM card yet. And look at this. We have the product model, UZ801. So this should be compatible with OpenWRT and OpenStick. Now let's download the SDK platform tools or the ADB because we need to check internal if this is really the device that we need. Just showing how ADB is done on Windows and on Linux. Yep, the device is now in ADB mode. For Linux, you just install the ADB package from your package manager. And you can get the ADB shell by executing ADB shell. And we have root access. There's only 2 CPU cores available because this thing could get hot. This thing should have 4 cores. You can execute modem AT commands via modem_AT. And here's the system files if you are curious. Just be careful, don't delete anything or the system may be broken. And here's the get prop from Android. And you can see it's an Android KitKat 4.4.4. So this device is really an Android phone without the screen. Now on this one, I just did some screenshots on the internal of the unit and we'll see what it looks like. Just pulling the screenshot from the unit. And as you can see, it is an Android phone. Okay, now let's disassemble the hardware. There are only 3 screws, and I hope I do remove them. Inside there's a RF shielding, and there's some pins. And you can see on the screen on which these pins are. At the back of it, there are the power management IC and the Wi-Fi IC. And of course, the PCB text saying UZ801, which proves this is what we need. And internally, there is no thermal pad on the SoC, which is bad because it could get overheated. So if you have a thermal pad or a thermal, like this one, you can just put it in. Please make sure you put exactly the size on the SoC. This is a bad example, to be honest. Now we're going to download the EDL tool. This will allow us to back up the stock firmware. Of course, Also to restore the stock firmware. Just be careful because this could break your device if you don't use it properly. I'm not gonna go through the steps in installing. You can just read it on the Git repo. Do not skip this step because if you break your device, this can save your life. Now, this can also be used on Qualcomm phones. So if you have a repair shop, this is very useful. We are focusing on the eMMC flash. So we're dumping the whole flash, dumping a folder of the partitions, and to restore it, you just execute those commands. Please make sure to print GPT first so you know the GPT layout. Now we're going to enter the EDL mode. By default, we are on the Android mode and also the Ethernet mode because they can use, this device can be USB tethered. So again, ADB devices to list the devices in your system. And ADB reboot EDL to boot the device to the EDL mode without needing to short the EDL pins. If you cannot do ADB reboot EDL, you can short the EDL pins to ground. And as you can see here, you have the 9008, which is the QDL mode. We are now ready to do the dumping of the stock firmware. We are now going to dump the firmware, but first, checking the GPT partition layout. Please make sure you have enough disk space before doing this. These devices have 4 gigabytes of eMMC, so make a 4 gigabyte space. We're going to proceed with dumping the stock firmware now. Use the command as on the screen. This might take a while, so grab a coffee or something. So just checking the size, and we have 3.7 gigabytes of the dump firmware. Next, we're going to compile our custom OpenWRT. For OpenWRT, we are using HK Fortis MSM 8916 OpenWRT. And this is the most latest one that I can find that supports UZ801, UF02, MF96E, and M9S, which are pocket Wi-Fi. However, the problem would be there's no receive and transmit stats on the display. So we're going to build this without using GitHub. So we're going to be using the local snapshot builds. This requires that you have a Linux on your computer. And of course, enough space, like 60 gigabytes of free space. To install the custom firmware that we have compiled, you have to enter EDL mode and then flash open WRT. This will also back up the modem partitions so you do not lose your IMEI and other calibration data. If you have encountered a problem such as no network, you have to do these steps. I never had to do these steps because mine worked perfectly after flashing. And of course, credits where credits due. If you get a modem or a dongle that doesn't have a lot of bands, you can enable the extra bands by using this guide. This is mostly for the UF02 chips. So if you got the UF02, I'm thinking that is the one with the white and red on the dongle. So you have to do these steps in the stock firmware before flashing OpenWRT. If you have that UF02, let me know. So this is the band configuration for Europe, which has all the bands except band 28. Now this part, I'll just compile the OpenWRT. This will also take a while, so grab some coffee. I might provide the binary of the compiled version, but HK Test also has a compiled version if you want to check on their Git repo. Again, huge credits to HK Test for this project. But of course, custom OpenWRT, you will be able to install your packages. We're going to use the configuration for UZ801. You can also read on how to compile OpenWRT on the OpenWRT wiki. Okay, we can now make menu config so we can install our preferred packages. Be sure to save and exit after you do this. And since we have 4 gigabytes of eMMCs, you can install as much as you want. Now, after you have built it, you will have this output, and you have to copy the binary files to the EDL directory. And of course, boot the device to EDL mode, similar to what we did earlier. So we are now going to proceed with flashing the OpenWRT to our modem or 4G dongle. Please make sure that you do not interrupt the flashing process or the dongle will be damaged or bricked. The device should restart automatically. And once it does, it should boot up to OpenWRT. And as you can see, we have now OpenWRT on our dashboard. All CPU cores will be available, and this might make the device heat up. So I suggest you set the minimum frequency and disable the 2 cores as necessary. In disk space, we have 3.25 gigabytes of total disk space. And the temperature, you can see we have 45.4 Celsius, which is a bit high. If you want, you can add a thermal or a heat sink to the shielding of the device to reduce the temperature. You might have to drill some holes on the plastic. Just exploring the OpenWRT that we built. So the SIM card is detected and we are connected to Smart. For the band locking, you have to do it via command line because there is no package for band locking. You cannot install packages here because there's no pre-compiled package. So if you want to install package, you have to rebuild it on your development environment. You can set the LED purpose here. In this example, I did it to be a heartbeat LED, the red one. AT commands, SMS. You can see we can access the SMS from the SIM card. AT commands, you can set AT commands too. But a note, if you want to change the IMEI, you have to do it on the stock firmware, not on the OpenWRT firmware. You can set the CPU scaling here to make it cool. Or there's USB gadget support. You can make this thing as a USB mass storage device. Now, a note for the wireless. The wireless of this stick doesn't perform well. That means you can get disconnected and might need the stick to restart. So just use the USB tethering method. There's a TTL for anti-tethering configuration if your ISP implements anti-tethering. There's Cloudflare Zero Trust OpenVPN installed. And the statistics, we also have this. We have to enable the thermal so you can monitor the temperature of the CPU at all times. So you can adjust your room temperature. Here's my sample. It went to 60 degrees at one point, and my room temperature is 31, and the stick has 50-degree temperature, which is a bit high. Now, this is the iPerf test using the Wi-Fi. It doesn't look good. Now, for the USB tethering part, this is the iPerf test, which is much more stable. And here are the bands available on my device. Now some speed test. Now my area doesn't have a good cell coverage, so I'll definitely tank the speed test. There is no port for external antenna on the device. We only have a PCB antenna. Just checking the TTL bypass. And it works. And of course, the speed test. Again, my area sucks with the speed test. I'm already using the best network, which is smart, on my area. And that is all for today. Future projects, I might install Ray Hunter to detect fake cell sites. And of course, full credits to the following people. And thank you for watching. Hit like, subscribe, and comment if this helped with your ongoing endeavors.